Hello everyone. In this tutorial I want to show you how to reverse GTA San Andreas from the very beginning. So let's start. The first step is to open IDA. I have both 7.0 and 7.2 version, but I usually use the 7.2 version because it's good. There's not much difference, so that's fine. So we first have to open our exe file. Once we open it, you can see that it is analyzing it, and it will take some time, so be patient here. And after a few minutes it will let you know here that the analysis has completed, and once it has completed, then you can do whatever you want with it. So but I will close this because I don't need to wait. And you can see that it generated the IDB file, and then instead of analyzing it again, you simply open the IDB file, and you can share this IDB file with others to share your progress. It is still analyzing it, but like I said, we don't need this one, but you have to wait. I have this IDB file. Oops, I already have it opened here. This is the IDB file that I have, and I have all of the functions in here, and you can get this IDB file from my Discord. Just go to this link and download it. So I want to show you that how you can add structs and enums to your IDB file. Now you should get the snowman plugin, and let me show you why. If I press F3 here, you can see that I have a decompiled struct here, and this is very useful. So you should get the snowman plugin. Now depending on your version, you can download this. I have the 7.2 and 7.0 version, so I will download this one. And once you download this, you just go to your IDA installation folder and go to plugins. Just copy paste both of these files in here, and then you simply restart your IDA. Now here you can see that I have the struct, so let's add the struct to our IDB file. Now let me show you from the beginning. To add a struct, we can simply go here, edit, add struct type, or we can just right click here, like this empty space. Right click on this empty space and click on add struct type. Wait, let me copy paste the name here. Yeah, there we go. So now you have to press the D key. If you press D, it will create a new field here, a new member for the struct type. And if you keep pressing it, it will change the type of the member. So this is 1 byte. This is DW, which is word. It will give you 2 bytes, and this this one will give you 4 bytes. You can look right here. As I press the key, if I click here and I keep pressing D, you will see the size is changing and the type as well. So I can click right here and I can add more fields. We can add as many as we want to. We just have to click right here and press the key D. So I'll remove them. And let's add our struct in here. So the first one is 32 bits, which is 1 byte. 32 bits is 4 bytes. So this means that we need dd, because dd equals 4 bytes. You can see we have 4 in here because we have 4 bytes now. And then there's some padding, which is 8 bytes. 8 bytes. We can define 1 byte here, and I can define an array of 8 bytes. So 4 bytes and 8 bytes. 4 bytes and 8 bytes. This is an array of 8 bytes. So we got here 0xc. In decimal it is 12 bytes. So if we go 4 plus 8, we get 12 bytes, and this is 12 bytes now. So let's add more. Then we have 4 bytes in here. Then we have 4 bytes, 4 bytes, 1 byte, 1 byte, db, which is 1 byte, and then we have 2 bytes. Oh, hey there. Nice to see you. And then we go 1, 2, 3, 4, 5, 6, 7, 8. Okay, let's go. 1, 2, 3, 4, 5, 6, 7, 8. Okay, now let's just give this another look. 4, 4, 8, 8 bytes, 12, 4, 4. And by the way, you can see this is F56 and this is 0x38. This is in hexadecimal and this is in decimal. Let me show you this. If right here 56, you can see the hexadecimal representation says 38. It is just a name, nothing else, so don't get confused here. So 1, 2, 3, 4, 5, 6, 7, 8. 8 members have 4 bytes. 8, and we have 2 bytes. Okay, so we're looking good now. Let's take this. Now, by the way, When you want to change the type, you click on it and then you press the key Y. This will allow you to change the type. And if you want to change the name of a variable, you press the key N and then you change the name. Okay, so here we have some clues in here. We can see that the first, now this is the first member, field 0, and the first member contains a pointer to a visual table. A visual table contains visual functions. The first 4 bytes are used by visual table. We can name this, I'll name it here. We can name this to vtable. And this is giving us a clue here. We can see this, the type is cped here. So I can click on this and press the key Y and change the type to cped. And then I can press the key N and change the name to m_p_fed. So we have like 2 members now, which is a great thing. Now what is this and where are these? Let's find out. Okay. This is a bit interesting. I pressed the key F3 to decompile using Snowman plugin. The type here is SO. So this one. We are looking at F8. Okay, so this means I press the key D again to change the type of the variable. So we'll make this 4 bytes and press D again one more time and again. So now we split the 8 bytes into 2 members of 4 bytes. So 4 and 4. Together they are 8 bytes. So this is the member. Okay, now it is a bit more clear. So field 8 plus 16. So I'm guessing this is another task. I can change the type to ctask pointer. Okay, there we go. And I knew this was ctask because I looked at these. Like, look at this. I already have. We can right click on these and click on enum. So this is how I already knew that I was looking at some task. So this is another task here. So I can click on here and press the key N, and I can say some task. Okay, it says create next subtask. So we can say, so if this says create next subtask, this is our subtask, and I can say oh, wait a minute, I just remembered one thing. This says ctask complex, okay? We already have a complex task. So this means I can click here, press the key Y to change the type. Sorry, no pointer here. And there we go. So if we go back here, now it makes more sense. Now I wonder what now I know this I think these are the constructor classes. Sorry, constructor functions. Okay, it is the same function. You know what? Let me check it here. Now, lucky for us, I have the Android IDB file, and it contains the name of all functions. Okay, so you can see this function is called create subtask. We can change this. And we can set the enum here. Oops, sorry. Much better now. And by the way, okay, it looks good. So we can right click here and say task, right click, enum task. Okay, now it is looking good, and that is a great thing. Oh, hey there. If you have any questions, you can ask me here. Now, what is this? Field 28. Okay, first let me change this to this. Okay. What is this? It's a bit weird. Let me check it here. I see. Go to point and stand still. Okay, so the second parameter is a vector. I see. It makes sense. Sorry, the first parameter is a vector. This one is the ECX. Let's see. Oh my god, what is this? Okay, I see. Um, it makes sense now. XYZ. Okay. This is a vector. Now, the reason I know it is a vector is because I was looking at this. Okay, so here we have a vector function that we are calling. So we then go from here to here, and we are assigning this to this. So it was float pointer, and then I saw this. So then I immediately recognized that this is a vector, and there we go. And since the name says go to point, so I know this is a point here. So now we have 1 2 3. Yeah, we still need to reverse these. Let's do it. Well, the thing is that if you you need to know C++. If you know C++, you know, like the basics of C++, like the pointers, you know, and you can learn this from any tutorial. You can just go like tutorials point, and you can learn how pointers work. So if you learn how pointers work, then you can come back here and watch these tutorials, then you will understand better. It is very important to know how pointers work and how like memory works in general. If you learn these things, then reversing will be a lot more easier, because I'm trying my best to teach how reversing works and how you can like um, add add like structs and everything to your IDB file, and then reverse code, and this will allow you to create mods. You can create any kind of mod you want to. Okay. Now what else do we have? Now what is this? What is this? uh, 1 2 3. I see. Target point. So what is this? We can say m underscore p. Now 1 2 3. 1 2 3. So here it says that it is the target point. This means we can press the key N. Target point. So you can see it's all about like clues and everything. You look at the names of the functions, the name of the different classes and the members, and you can see that how it's being used, and depending on that you name the members of the struct and you name the types. So now I need to press Y and do vector. Oh wait a minute, it's oh my god, it's not actually vector pointer, it is C vector. Wait a minute. Oh my god, I made a mistake here. This is meant to be C vector. There we go. So C vector is basically it takes like I think 16 bytes. Wait a minute. Sorry, it takes 12 bytes. 4 4 4. It has like 4 floating points, and I will show you in my IDB file. Now I know most of you know what C vector is, but I just want to, there we go. So the size of C vector is 12 bytes, and I hope that explains it. So we have this, and this is also meant to take much better now, much better. Now what else do we have in here? We need to reverse these, and this and this. Okay, no problem. Let's do it. Oh, there we go. Okay. I see. It makes sense now. Okay. We can change this to unsigned ID, unsigned NT, 14 and 10. Let's change this to C vector. What is this? Okay, there we go. Okay, so we have this in here, and so create subtask. What is the subtask? The subtask is Let me see, what is the subtask? Read next subtask. So read subtask. What is this? This is very confusing now. Let me see. The first one is a task. Okay. Uh, oops, got a mistake in here. This to the uh get felt. Oh, this is C vector. I see. C vector. Where was I? Where was I? Okay. Uh, we have 1, 2, 3. Third one. Oh, the calling convention. That's why. I see. I think it is this call. Let me check the calling convention here. Hmm. This is very confusing now. So it takes like 4 parameters. Okay, I see now. I see. It takes like 4 parameters. Means 1, 2, 3, 4. We can remove this one. Let's save it. Make it this call. Okay, now it's good. Alright, now it is good. What else? I wonder. No, this is not it. Now what about here? Okay, let me just try to confirm this. No, this is not it. Then, and what the hell is this? Okay, there we go. I think. Forty-eight bytes. I know this is. Oh my god! I don't know what the type here is. There. Like, I'm really thinking. Uh, so okay, I have an idea. I have an idea. I think that what we can do is that um, I'm wasting too much time here. So I think what I should do is that I can print the yeah, I can call this function here get ID and like this, you know. Yeah, like this. This should help us. Like I can first hook this function. When I hook this function, then I can figure out um, what the which subtask is used here. And once I get the ID of the subtask, then I can check which subtask is being used, and we can then set the type here. Right now it is a bit confusing because there are many uh, yeah, there are many subtasks. So who knows which subtask we're looking at? Okay, so moving on. Let's finish this. Okay. Or wait a minute, we can just start GT San Andreas. Okay. Okay, I think I have an idea. We can start GT San Andreas. And then we can use reclass. I haven't used reclass since a long time, but I hope I remember how to use it. Let's create a new class here. Okay. So wait a minute. Let me first did all of this. Yeah. Okay. Oh, what the hell is this? It says. Okay. Oh, yeah, well, never mind. Let me just. I think I don't remember how to use it. Anyways, no worries. We still have cheat engine for the rescue. Okay. Now what we can do is that we can just start cheat engine. We go to memory view. Fourth, eight. All right. So, yes. Oh my god, this is going to be difficult this way. I don't think we can use cheat engine for this. I mean, we can technically speaking, but it's going to be hard. Uh, because the problem is that they all have a virtual function which basically get task type. Or wait a minute, wait a minute. You know what? I'm just overthinking this. Okay, I'm just overthinking this. Let's just do it. You know what? Let's just do it. Okay. Let's just go to this address. Okay. Put a breakpoint here.
It's my constitutional right, bitch. You should run away.
I have constitutional right to kill you. Okay. So any pets for investigation? No. we need to trigger this breakpoint. Okay, I think it gets triggered when you kill some pet. Oh, there we go. The breakpoint was hit now. So here ECX contain wait a minute. Okay, this is the exactly. So this is the ECX, the this, you know, as we call it, the ECX, and we can just take this. All right, and then okay, 1 2 3 okay, 1 2 3 4 5 1 2 3 4 5. The fifth one is the get task type. Okay, let's do it. So this means 4 multiplied by 5, you get 20. So this means, oh sorry, wait a minute, first let me get the ECX here. This is the V table, you know, like the you know the first member is the V table. So we just, you know, so I took the ECX, then I put this here, and we get the first member. Oh, wait a minute, let me change this to hex. And yeah, this is the V table. So now we have the address of the V table. So now all I need to do is, okay, the way how this works is that 1 2 3 4 5, we need this function. Okay, so as we know, 5 multiplied by 4 is 20, because these are aligned by 4 bytes, you know. The size of each address, the maximum size of each address is 4 bytes on 32-bit programs. So this is you know, this is 4 bytes, 4 bytes, 4 bytes, 4 bytes, and 4 bytes. So this is the fifth one, 4 multiplied by 20. So this means plus 20. Wait a minute. Let's do the hexadecimal value. Plus 0x14. Sorry, 0x14. We get this is 0x86 FTBC. 0x86 FTBC. 0x is now let's go to this address. Oh yeah, it took us right here, but that is fine, not a big issue. Okay, so it should be actually 4, but that is fine, not a big problem. We had to actually, you know, do it this way, like 4 multiplied by 15, and then we would have, sorry, oh my god, 4 multiplied by 4, we get 16, which is 0x10. Okay, now we got the task type. So this function is being used. Get complex standstill. I see. Now we know which function is used. Perfect. Okay. Now the thing is that the reason why you don't see the members and everything in here, it is because it doesn't have any members. Okay. We need to define the members and everything else. So I guess we have to reverse this. But we can do that later. For now, we can just leave it as it is, you know. Or you know what? Let's do it. Let's just do it. Not a problem. Um. Okay. Let's go right here. Mm. All right. We need to find the constructor for this class, and I wonder where the hell that is. Nope, we don't have it. This function. Okay, now this is getting annoying. This is getting very annoying. Okay. No, let's go right here. Oh, we already have it here. Oh my god, the stupid name. Okay, there we go. Okay, there we go. So this is the constructor, and oops, what happened? Never mind, let's just go window and reset our desktop. No, cancel. Press F3 to decompile it. SO. 28 40 bytes. Wait. And we can add this stuff in there now. Structs. Struct type. Struct type. Or wait a minute, let's just or we can just say delete struct type. No. Now we have a problem. Like, how do I delete this? How do we delete this type then? This is a problem. Or maybe I can just do this, you know, I can just go like this. What? It's not working. I can just call it like 1 or something, or 0. Is probably name is invalid and used in the program. Can create structure. This is a problem. This is a problem indeed. What about this? Okay. How do I fix this? I wonder. Okay. Now this was unexpected, and okay, you know what? You know, but I hope you get the idea. Okay, this is like the type for C task complex go to point and stand still. Oh yeah, it is a long name, but yeah, this is the type. and you know how to add them. You just go to edit, you say a struct type, or just let me do this, c underscore, or just let me type any type, abc, rename. Okay, now it works. There we go. Finally. Okay. I'm sorry, it took me some time to figure out. Now we can press D, and this should be 4 bytes. Okay, so we make it double word. I'll say ctask complex because this is a complex task. And then we have 12 bytes for now. This means we can get rid of this. Then we have 4 bytes. 4. Then we have 8 bytes. Sorry, we have 8 bytes. Then we have 4. And then we have 1 more byte. We got 36, and I believe the rest is like last 3 bytes are the padding, because that's how compilers work. Yep. And there we go, we have 28. 0x28. 0x28. Okay, now we're talking. Now we are talking. Yeah, A. It is pretty funny. Okay, now we can go back to that function. Right here. Okay, there we go. Okay, so basically this is C vector. Okay. Change this to float. What is this? What the hell is this? I think those are the flags because I see some bit operations in here. So I'm saying these are flags. What are these two? 1C and 20. Now this is also 3 and 4. So what is A3 and A4? This is a bit interesting. A3 and A4. Okay, so we can say we can give this a good name. Okay, there we go. Now the function has a good name. Okay, yeah, exactly. What are these two? This and this. I don't know. Anyways, we can reverse them. That's fine. We need to copy this. This is float. There we go. Select move state. Okay, so what is this now? I wonder, what is this? This field, and this, of course. Now these two are. Oh, wait a minute. Yeah, these two are floating points. I know that for sure. But this one, this one is something. Oh, this is the radius. F radius. I know it is radius because we are, multiplying it together. So that's how I know it is radius. What is that? Okay, this does not make any sense. Oh, okay. Now I see why. Now I see why. Okay. We can make this. Just let me do this a bit here. Okay. So let's look at this. Okay. Yes. So right now we have A1. We change to we first change this to this call, and then we select this right here. Yeah. Okay. Return 10. 4. We have 4 parameters, 1 2 3 4, and this is the ECX, right? Yeah, this is the ECX. I see, this is the move state. Now it makes sense. Okay, we don't have an enum, but it's fine. Move state. So this is the move state. Okay, and okay, so we can add an enum for the move state if we want to, and now I'll show you how to add an enum. I'm sorry it took me so much time to reverse and everything, but it happens. Sometimes these things will take more time than you expect, but it requires patience. Okay, so we can just go like right down here and we can say add, then we can say state decimal, and add in a member. Okay, so we can press the key N to add a new member. N, you can say this, and let me remove this, very annoying. Press the key N again, and then we add this one. We press N again, and then we add this one. We press the key N again, and we add this one. Press N again, and we add this one. N again. One more time, and we add the last one. So now we make sure that it's correct. None, still, turn, left, right, walk, jog, run, sprint. 1 2 3 2. Okay, it's correct. So now we can just go like this. we just right click and then choose Enum, and then we can set them. Yeah, this is more readable now and better, of course. So yeah, that's how we do it. What is this? What the hell is this? Oh, I see. um v2 ped. Okay, this one is ped. There we go. Let's see vector. Oops. The last one is radius. What is this? Okay, so this one is also radius. Okay, so when we are outside the radius, then we have to sprint or run, and yeah, when we are outside this radius, okay, this one. Okay, when we are outside this radius, then we have to run or sprint. But when we are inside this radius, we are inside this sum radius, then we have to walk, which is, yeah, it is understandable. So this one is also radius. So this is f run or sprint radius, and this is f max radius. Or we can just call this radius. It is yeah, it makes sense. What is this now? Field 1c. Yeah. The 1c. I see now. Oh. dword pointer. Wait a minute. So this is not it is not actually a floating point, it is an integer, which is quite interesting. Okay, so we only need this one root to be reversed. So let me check this function again. Investigate fed. So this is also some kind of like floating point. It is a floating point, but I don't know what exactly it is used for. Which is, you know, a bit interesting. 1 2 3 4. This one. All right. Okay, that explains it. So far, we know this is it does have something to do with the, you know, with the radius, but I don't really see it being used anywhere. Oh, this one. Let's see. Most state target position radius. So this is also some radius. Okay, which is quite interesting. Okay, so now the question is, why do we have two floating points here for radius? And let's see. Let me first give them. Okay, so now we know what this is. Okay, so this is also some kind of radius. Okay, so we can just name this. Okay, and then we can call this. Okay, there we go. Now it makes sense. So this radius is basically used to set the move state. Okay, we can just write a comment. We can say um okay, so this makes sense now. This radius is used for when pet should stop moving after reaching the point, and this radius is used for walking, running, or jogging, depending on the move state. Sorry, depending if the pet is inside the radius or not. So we have this now. This has been fully reversed. This is just some padding which can be ignored. Okay, and now you have a complete struct, which is amazing. Okay, so now if you go back here, now we can see that we have the complete struct. Okay, this is like pretty amazing. And now, of course, we can just say flags and um um I think this means that now what I don't know what the flag is. We don't know what this flag is, so I don't think we should name this or anything. But yeah, I think that it mainly it is checking for that if the data is same or not. We can just, or maybe we can just do this. We can say if yeah, we can just name this like this. So we need to now reverse the flags, of course. um what is this? Okay, okay, now I see. The first bit is basically used for um uh, Okay, so you can see that the oh, sorry, oh my god, this is like the third bit. Okay. I think the first bit here is used for checking if the player should start moving or not, and and what is this flag? Okay, I think we can do this some other day because now I'm a bit tired, and and yeah, but I hope you get the idea how to reverse everything. And it's actually very easy because you know you have so many clues, and you know you can easily figure out names. And you saw that how I used cheat engine um for getting the name of the virtual function. But this is not how you should do it. You should always use reclass because reclass is better, and it is designed for this kind of tasks. The thing is that I haven't used reclass since a long time, so I probably forgot how to use it. uh, and yeah, that's pretty much it. All right, I think we learned enough for today, and so we reversed this class, and we reversed. I think it was one more. Yeah, this one. We haven't fully reversed it yet. We still need to reverse it completely, but it's looking good now. It is definitely looking good, much better than before. Okay. um 14, 18 and 19. You know what I would do if I want to reverse these? I would just hook this function, and then I would, you know, I would like log them. I would like print them, and I would see what values they have. Like for example, you know, I have like reverse code in here that I have reversed. I would just like, you know, like hook this function, and then I would print print this members, and I will see their values. So the values would change as I'm moving, and you know, as I kill pets, the other pets would come and you know investigate them and see what happened. So then these values would change. So then I would be able to figure out what they actually mean. Okay. Okay. So thank you for watching. I will see you guys in the next stream. See you there. Bye bye.